All right, here we go. Next example. So this is probably the one that is the most intricate one. NO3 minus. And guys, I'm going to need like this whole area. That's why I think I gave you like an entire area in which to do it. So this is something called the nitrate ion. I'm calling it an ion because it carries a charge. So the first thing we have to do is figure out what is our central atom. So we go look at the electronegativity chart and we compare nitrogen to oxygen. Now there is an indicator kind of gives this away, the fact that there is one nitrogen and 3 oxygens. But let's take a look at it. Nitrogen is 3.0, oxygen is 3.5, the lower one is nitrogen, therefore it is the central atom. Now we got to count up valence electrons. So, nitrogen, how many valence electrons does it carry?
6.
5. Are you sure it's 6?
5.
Hey, well,
I really do.
I'm trying to fill them 1. And 2, that's just not an appropriate way to speak to another human being. Alright, so right here,
You talking?
nitrogen has how many valence electrons?
5.
5. That's 6. 5. Nitrogen has 5. Now, oxygen has 6. And there are 3 of them. So 5 plus 6 plus 6 plus 6. Ooh. And now,
23.
now we have to account for one more thing. If it was NO3, then it would be 5 plus 6 plus 6 plus 6, right? But this thing's negative. And that means it has done what?
Got rid of
It's added 1 electron. And so we got one more additional electron that we need to put in.
4.
So our total here is 24. So when we do this now, we got to account for 24 electrons. So we already said that nitrogen was going to be the middle. So we'll put nitrogen in the center. And we're going to put 3 oxygens coming off of it in single bonds. Oxygen, oxygen, oxygen. Yes?
Are you drawing this right the first time, or are we going to draw it?
I don't know if I'm drawing it right. Like literally, this is one of those where we'll check it for Vsepr later on, and we'll see if I've drawn it right. So when you do this, how many did you just use up? 6. So that leaves us with 18 electrons to place. These oxygens, we always start, we work outside in. So these oxygens are looking to each gain how many more electrons? 6 more. So this oxygen right here wants 1, 2, 3, 4, 5, 6 more. It's got 2, gives it a total of 8. And oxygen is not an exception. This one here, 1, 2, 3, 4, 5, 6, 7, 8 in the bond. So far we've done 6 and 6. There's 6 more. Well, that's good because we can put those 6 right here. 1, 2, 3, 4, 5, 6. Minus 6, none left to place. Now, we go and look and see, is everybody happy? And we have a little bit of an issue here. Oxygen's got 8, oxygen's got 8, oxygen's got 8. But what does nitrogen have?
6.
Only 6. Well, is nitrogen one of our exceptions?
No.
No. So nitrogen wants how many? 8. This is the first time I've gotten to introduce something called resonance structures to you. And here's what a resonance structure is. A resonance structure says that we have 3 things here, 3 oxygens, and we need to make a double bond somewhere, right? But we have a little bit of a problem because we could make the double bond be there, we could make it be there, or we could make it be there, couldn't we? So what you do, guys, is you just pick one of them. So I'm going to pick that one right there. I'm going to swing these in to make a double bond, right? We always take an electron pair, we swing it in. So our new drawing ends up looking like this. Nitrogen, double bond, oxygen. These are gone now, leaving us with 4 electrons on that oxygen. This one still has 6. And this one still has 6. Okay. What's that? That's okay. Is nitrogen happy now? Is it? Yes. Okay. Vsepr. Did I draw the structure correctly? Guys, this is there's a bunch of stuff we still got to do. But let's, before we progress any further, make sure we've drawn this picture correctly. So, how many things are bonded to the central atom? 3. 1 oxygen, 2 oxygens, 3 oxygens. Are there any lone pairs on that nitrogen? No. So, when you look to find 3 and 0, you see that this thing is trigonoplanar. And have I drawn it correctly then? Yes. The bond angles is 120 degrees. Hybridization would be sp2. We got a little bit of a problem. What type of thing was this, guys? What type of thing was it? It's an ion. Therefore, just like in the past, we've got a brackets and a negative. We also have a couple of other things. I told you earlier that we have something called resonance here. Was making this double bond the only possible answer? No. So you have to draw all of the possible answers. So, it could have been that way. But, it could. I know you guys are thrilled.
Not at all.
I'm aware. We also could have taken one of these electrons, any of those 3, and made the double bond be right there. So, we're going to draw that one now. No, it's not the exact same thing. It's a different oxygen. Two, three, four, five, six. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. And no, these are not the same thing. There's another possibility right there. Is that the only 2 possibilities?
I wish so.
And I do too. But what else could we have done? Could we have made the double bond be on the bottom oxygen as well? Yeah. Alright, so if we didn't do it this way.
You still put 6 yeah, you put 6 on it and it's so bonded.
Oh, you're wrong.
You're right. Thank you. There should be 4. What was that? It's okay. So we're 4. Now, this one we could also take an electron pair and swing it in. So you end up with nitrogen, double bond oxygen with only 4 electrons on it.
Oh, good job.
Wow, thank you. I'm flexible.
Do you have to only label one of them with like the degrees and the name?
Yeah, that's fine. I might even just put it in the middle.
Are you sure?
Yeah. Hey guys, in order to get this problem right, guess how many of those drawings you have to put?
3.
All 3 of them. These things are called resonance structures. And they are different, Carly, because this oxygen is different from this oxygen, is different from that one. Alright.
Don't they make up the same molecule?
What's that?
Same thing though, aren't they?
They're all the nitrate ion. It's just 3 possible resonance structures for being able to symbolize them in something called a Lewis diagram or a Lewis structure. Can you stop the... This is Gerby from Manchester. Out.
Oh my gosh.